Hello and welcome to today's lesson. Today's objective is students will know that rigid transformations create congruent images. Remember, congruent is just our geometry word for the same. So first of all, let's talk about what are rigid transformations. What does that mean? So rigid transformations create congruent images. The rigid transformations are translation, reflection, and rotation. Dilation does not create congruent images. It is not a rigid transformation. So from here on out, I'm not going to talk about dilation other than to say that it does not create a congruent image. So let's look at this. A quadrilateral transformed. A quadrilateral is just a four-sided shape. So we've got this wonderful image over here of a quadrilateral. And we are told the measure of angle B is 95 degrees. The measure of angle A is 90 degrees. The quadrilateral is rotated 180 degrees. So what I know right now is angle B is 95 degrees. So that's this angle right here is 95 degrees. And I know that angle A is 90 degrees. So here's angle A. And it is 90 degrees. And then the quadrilateral was rotated 180 degrees. What is the measure of angle B prime? Remember the prime there, that little apostrophe symbol? Just means the point B after it is rotated. So I know that I'm making congruent images. That means angle B is still going to be 95 degrees. The next question asks you, what is the measure of angle A prime? Well, again, what do I know about angle A? Angle A is 90 degrees. So A prime is still 90 degrees. Because remember, we're making a congruent image. That means the angles are not going to change. So now let's look at this triangle. So this triangle is going to be translated 2 units left and 5 units down. Okay? So what is the length of line segment H prime J prime? Well, we know that line segment H prime J prime would be the same as line segment H J. And that one is 1, 2, 3, 4 units. That means that the new image they'll still be 4 units. Then we look at what is the length of line segment J prime K prime. So I'm going to again look at here, J to K is 1, 2, 3, 4, 5 units. That means J prime to K prime is going to still be 5 units. Remember, congruent images means I can measure the pre-image to give information about the post-image. Okay, so now let's talk about this. Where is the point? So which quadrant is point A in after a given transformation? So in case you don't remember, the quadrants of our graph here is quadrant 1, 2, 3, 4. And they are always written in Roman numerals, okay? So I can see that A is starting out right here. That's in quadrant 1. So I've got the mapping information. So if I have x, y, x and negative y, that means my x value stays the same. And I use the opposite of the y value. That means that that point's going to go down here. It's reflected over my x-axis. Well, now it's in quadrant 4. Well, what if, erase that real quick. What if now I do y negative x? That means I'm reflecting it over the y-axis. So if it reflects over the y-axis, it's going to be right here, which is in quadrant 2. Okay. So what if I do x minus 8, y plus 2? That means I'm going to move it left 8. So we're going to go left 8, 1, 2, 3, 4, 5, 6, 7, 8. And then up 2, I'm in quadrant 2. And then finally, what if... Okay, so now let's look at what if I have x minus 5, negative y. So x minus 5 means that I'm going to subtract from my x value. So I'm moving left 1, 2, 3, 4, 5 right here. And then opposite y value. Right now my y is 4, so I'm going to go down and be at negative 4, which is C. That takes me down into the third quadrant. Okay, not too bad. You just got to look to see where each of those mapping instructions takes you to. Okay, so finally let's talk about what stays the same and what changes. So, if this triangle, so this triangle right here, is reflected across the line x equals 3. So first, where is my line x equals 3? Well, that line is a vertical line right here at x equals 3. That's my mirror, okay? So if that's it. So we're going to tell if the result is a change to the given characteristic. So we're talking about do different things change. So the first thing is the perimeter. No, the perimeter of figure does not change. Because the perimeter is going to be the same in congruent figure. Same thing with my area. What about the slope of line segment HJ? So let's look at where that is. So line segment HJ is right here. Should have done that in green. Line segment HJ is right there. So when that's reflected, it's still going to have that same slope. So that one does not change. What about the slope of line segment KH? So let's look at where line segment KH is. Line segment KH is this line segment right here. Well, that one, when I reflect it, you go from being positive to being negative. So that one does change. So that one, yes, changes. What about the length of line segment KH? Well, the length of any line segments are not going to change. So that does not change. And finally, let's look at whether the measure of angle J would change. So here's angle J right here. When we reflect it, it is still going to be the same measure. No change. So the only thing that might change would be the slope or possibly locations of things. So locations can also change. So those where those points are would change. Okay, so go ahead and do your practice in class and ask any questions. I'll see you then.